So this is how actually you can able to see your animations. This PEQ value, it represents your exact strain values, that how much amount of a strain actually it is falling on this. Okay, so this gives you like the stress values that you can able to see in this conditions. Now going back over here, what we can do is I'll just go to the loading module again over here. This was the load that you have seen, right? This was the load that you have seen. Now I would like to do some kind of a loading that looks like a completely different things. Let's say when I just go for an Excel sheet, it's a static condition only, but actually I'm just trying to represent this particular way. When my particular time period, that means here the time period is nothing but it's a zero value. I'll tell you what's the time period also now. When it reaches to something around like 0.1, let's say I would like to apply some 350. And when it reaches to 0.2, let's say I would like to apply only 250 over here. 250. And when it reaches to some 0.5, I can apply some 350. And when it reaches to 0.6, I can apply some 500. When it goes to 1.7, maybe some 800, it may fail, I think, some 450 again. And when it reaches to 1, it may apply again some 500. So this is where actually the load that I would like to plot. Okay, so this is kind of a loading that I would like to plot for this from 0.
Sir, hello, sir.
Yeah.
So can you mention the x-axis, y-axis heading, like in the column? In the column, what is that x-axis actually mean?
NR is nothing but it's a Newton-Raphson, okay? Load in terms of like a newtons. Okay, this is what actually I'm trying to do this. So now just copy this, copy these particular values. Now go to here. Now in this, go to an amplitude section. It's an amplitude one that I would like to mention. It's a tabular value. So you can just go continue, apply these values over here and give OK. Okay. So now go to this load that which you have already created for loading, edit that. In that, you just keep the value as a 1 over here, and then you just choose this particular amplitude one. So amplitude just that what we have created, that we have selected. That means, so this particular numerical 1 is going to be multiplied with a 0, multiplied with 350, multiplied with 250, multiplied with 350, multiplied with 500. Okay, this is an up and down curves actually. Okay, this is going to give some an error or it's going to solve. That we are going to see it right now. Okay, so let me fix up this and then dismiss. Now I would like to create a new job. It's a static varying load. The static varying load that I would like to solve it. So continue. So for the same 4 processes that I would like to solve. And then going for submit over this. Okay, my problem got completed over here. Now I can right click on monitor over here. This is actually it's a simple way it got completed again. Now I can right click on this and go for the results. I can just give OK. Now see this one. I would like to give a comparisons between both. Let me go and cascade the viewports or viewport create. So the two viewports that I would like to see this one. On this, I would like to load the results of a static loading. On this, I would like to load the results of a static varying loading. So two different things that I'm doing it right now. 229.704, 229.759. You can see the difference. That's what the difference that you can able to see it now. Okay, I'll show you the complete difference now. Where this procedure helps you out to do your dynamic problems also into a static variation. Okay. Now, let me click on this. I'm coming on to the steps wise. On the steps, 16 frames that I got created it, right? Now, let me go and click on the something. It's 0.61 something. Okay, it's 0.61 and my 11th increment. And I just go for my loading, it's 0.6, where I would like to apply a 500 loader, where I would like to apply a 500 loader. Okay. When I just come back here, and here also, I would like to go for the 11th one. That's again, oh, shit. 11th one, this is what. I need to click on this and come here and click on this 11th one. See, the time interval over here, it is 0.6178, 0.6178, but you see the difference it is. The load over here, it is like 228.704, 217.345 only. Okay. Let me go back and we will see at 0.7, or we can see at 0.1 actually. So we can see the much more difference actually in 0.1. Yeah. This is where it's a 0.1. So now I'll come here. This is 0.1. Now see this one, guys. If you just see the difference over here, in 0.1419, the load actually here, the stress that we are getting is 216. And in this particular things, without an amplitude that I'm going at, now at that particular same time interval of a time, the stress that you can see is like 49.9. As of now, Dennis, you understood what is the difference it is coming, right? So some difference it is coming. That's what you have to understand that. Is that clear?
These two figures shows the two increments, right, sir?
Yeah, that's
Like,
what. That's what actually the Newton-Raphson it says that. In my first problem, I'm just trying to solve it simply. I've just decided only this particular value. So it takes that automatically if it is a 0.1. So it takes like 500 into 0.1. So 0.1, it takes 50 loading. That's 0.2. Actually, what it will take is like 500 into 0.2. It takes 100 loading. So coming on at 0.5, what it will take is like takes 50% loading. Okay. So coming on like 0.7, that what it does is like my thing is like 500. So it does like 70% of the loading. So coming on 1, what it will do, it tries to apply like 500. But in this, what it is happening, we are controlling at at like how that particular load it is coming all this time I'm not giving in terms of like a second. I'm telling that it's a Newton-Raphson method. It's a Newton-Raphson time actually. So at an each and every interval that I'm just trying to control that particular load. Some initially what I considered is like a heavy vehicle came on my bridge and a low grade vehicle and again a heavy vehicle and again super loaded vehicle, a heavy vehicle with high load and again a super loaded vehicle. Okay, so like this I have considered it, but here actually what they have doing is something like the gradually increasing this. This is what actually the Newton-Raphson says. It tries to gradually increase the load, and then this is what actually with the support of an amplitude that you can able to vary your load as per your range, as per your request. You can also able to vary your load as per your request. So if you have only a one load value, then we will follow this particular procedure. If you have a set of load values, then we will try to work out on this particular. Okay, that when so this is where actually you can able to see this particular kind of things. But I could not say it's a 0.5 seconds. I could not say it's a 0.5 second. But when you have a load that which it looks like something. And I just go for an amplitude again over here. I can able to create a multiple amplitude threads. The periodic loading, when you have something like a periodic loading, then you can able to go and give these particular things. Or like when you just have something like a power spectral density, you can able to do, or you have something like over a decade of like a, for a decade of a time that what you have it, that you can able to give all these things. So this is what actually input I'm just expecting from you guys, like what exactly it's a spectrum that you would like to feed. It's a magnitude frequency with the damping, or like it's a simple tabular data with a time or frequency and an amplitude that you have. Okay, if your time or frequency that you have it, then you may ask me like, so this means that like 0.5 seconds. Yes, I can do this, right? You know, this is a Newton-Raphson method it is solving it. But for me, if I convert this as a seconds, at 0.2 seconds, this is what the load it is having. At 0.4 seconds, this is the load. At 0.6 seconds, this is the load. At 0.8 seconds, this is the load. At 1 second, this is the load. Maybe I'm solving it for 1 second. Okay, let's say like you want to solve the problem for 5 seconds. You can convert this. You can convert this. There is no issues. But still, there is a way of going up with like a dynamic requirement when you have to go for a dynamic requirement, when we should not, this kind of a procedure is not suitable, is like you have a continuous varying load spectrums that which is having a huge informations with you in that particular cases, or like it's a simple harmonic response. I don't know these particular number of cycles, how the loading it varies and all. I have only a one cycle that I need to repeat that particular cycle for 20 times, 30 times. In that particular cases that we can go for a harmonic loading, those kind of things. Or we didn't have any kind of these loads, then we can able to follow those particular procedures. Okay, like this, you can able to modify those things. Now you got the difference, like even in static also, we can able to go for a dynamics, but for what exactly the dynamic input it is required, that you have to feed for those particular things. Now this particular entire load that it is going on with this particular fashion. Okay, you got my point, Dennis?
Yes, I got it, sir. So like the input is in our hand. If the input value is only one, we can give like small increment. For other load values for the particular time we have, we can give like that also, right, sir? To kind of
Yes. Okay, so now in technically, if you dive deep, what's the difference between a static and dynamics when both are possible with the same things? Is inertia effects. In dynamic analysis, your inertia effects will consider it. In static analysis, your inertia effects will not consider.
Okay.
Understood?
Yeah.
Okay. That's what I have for today. I think we have Ashish also here. Let me save this, otherwise we'll lose this.
Kindly share this video today. I want to practice on this.
Sorry?
Kindly share this video today because so I can
Yeah, I'm
practice.
sharing it on every day, right? Okay, I'll upload it and then I'll give you.
Last 1 week, I didn't got any.
We didn't do much classes. That's only on Ashish things that we have done.
Oh, yes.
Something is there. I could have shared you all this, but we didn't record much.
I
Ashish,
thought the last week. Yeah, I thought the last week you guys completed the whole course. So, and even I checked, but I didn't even find any video in our group.
It's something at composite modeling only. I'll try to share you those particular videos. Okay. Okay, then you have any questions, please let me know so we can discuss on that.
I only have the question related to why dynamic input data is required for the bridge analysis. Like
that you have to tell me, because when I just go over here, there's much huge number of steps that I have it. It's a dynamic explicit or dynamic, which one that I would like to solve. It was quite difficult. So at least if you can show me one paper, I can able to tell like what way they have done. I can't comment on any kind of an input. So if you have an input, then I'll teach you like how to feed that in Abacus, because inputs are the major assets for your results. What kind of an inputs is? Anything that comes under an amplitude is a dynamic values. If it's a tabular one, that what you have, a time, a frequency, amplitude, any of these particular things that you have it, just let me know. So we can discuss on that. Or like you can specify that particular value. So this is what I am expecting from you.
okay.
Your vibrational loading that you are saying it. I was expecting with respect to the time, what is the load that it is coming on the bridge.
Actually, in my project, I need to draw on truss bridge. For that, almost half of the element is almost same, and half of the element is somewhat different. So for modeling or for drawing the entire structure in Abacus, what the way need to follow, sir? Like first I need to create one, and that can be like a copy. The copying process is it available in Abacus or not?
Yes. See, once this particular part is all done, you just copy this. Floor is there, right? You can just make a copy of this. So another floor, it can create it. You can rename that.
So my section is like the channel section. Can you just draw one channel section for me? Like I will give the dimensions.
Which channel actually? C
The
channel,
channel
L channel.
Yeah. No. That is like a L shape. L shape.
Let me go on this.
Actually, it is a combination of two plates, and one plate, each plate thickness is like 10.
That's what actually I need to see your drawing. See, L means I can able to do it like this.
Like this, okay. So the exclusion is like yeah, like this, like this. So after this, I need to.
Yeah. Yeah, this is how you can able to build your L sections. Next.
Yeah, I thought I need to. Create one particular plate and another particular plate. Then I need to join both like a L shape.
No,
So
no,
this
no.
is more
This is
easier.
single things. See, again, I want cross-sectional details why I have asked you, in
Yeah, yeah, yeah. I have.
realistically that your
Yeah,
bridge, this plate and this plate are welded with each other, or this is a
yes.
brought out part of an extrusion part. In reality, these are two or welded with each other, or it's a single extrusion part.
So we are taking one single exclusion part, right?
Yeah,
Like,
then this particular methodology is correct. If it is two parts are welded with each other, then what you have told, no, that particular process is correct.
yeah. Okay. Yeah, actually we have one,
Like
two,
you can
three,
copy
four,
this particular L parts a number of times. Copy this.
okay.
So now I have like in the assembly, when I just go, I can call up this two L parts. Have a two over here, like let me click on this. Okay, I have a two parts. Now that where you would like to fix it, you can just move and fix those particular things. Okay. Let's say like this, I would like to move from this position to this position. You can just do like this. I can able to copy of this particular batch. Once you know the position that you can able to slightly adjust.
So can I ask you one more question? Like in trust, we have diagonal members. So how we will place this as a diagonal
Sorry,
member?
interest.
How we will place this member as a diagonal? How the angle we will give? How we need how we will assign an angle for a particular member?
Like you can just go and rotate your an instance that you would like to rotate this particular things. Then it will ask you select an axis or a start point of the rotation vector that you would like to do. So in this, in which rotation that you would like to do it. Let's say I would like to rotate this and select an endpoint for rotational vectors of all those things. Then I can just select this particular things. I would like to rotate it for 90 degrees. I can just click on this. Okay.
Can you make it as a triangle by using these three triangular form?
Yeah,
By using these three.
These three are not in a perfect geometry, but let me try for this. Oh, sorry. I didn't select OK. Okay, slowly, because this isn't the same thing, but actually I could not able to figure out this because the position is not same, right? So still I could able to slightly rotate this and then I can able to fix this. Like this I can able. But if you just go with an exact dimensions of it, then there is no issues. Okay. So you can easily able to fix up this. Okay.
Okay.
So you have to play around this too. So that's it. Like there are other constraints also, like surface to surface constraints and all. That's why like when you just go up with the cross section, I'll try to filter out the many things over here itself. Once you call up to the assembly directly, the part should come into its own position. That's what actually a good design can follow. You should not play around in an assembly module. Okay. Is that fine?
Yeah, fine, sir.
Okay. Any other doubts?
No, sir. If I go through the work, I
Yeah,
will get
start
more.
practicing on this. I'll share you both the videos, and based on that, we can able to discuss further if anything is there. Okay.
So along with that, share that composite, how to make the composite section abacus.
Sure. Yeah. Okay.
Thank you.
Okay then. See you tomorrow. Bye bye.
Thank you.